we'll see arithmetic instructions in 8051 part 4. Myself Dr. Kurne Faiz Ahmed, Head Department of Electronics Science, Abida Inamdar Senior College, Pune 1. In this session we will see multiplication and division instructions in 8051 microcontroller. The 8051 has the capability to perform 8-bit multiplication and 8-bit division. The register B is exclusively used for these two instructions. So for multiplication and division instruction, only two registers are used, that is register A and register B. Let's see the syntax. So the syntax is MULAB. Meaning of this, it will do 8-bit A into 8-bit B multiplication and produces 16-bit result in B and A register. So in step 1, it will do multiplication between content of A and content of B. After the multiplication, the lower byte is stored in register A and higher byte result is stored in register B. So we can say that MULAB, it will do multiplication operation on content of A and content of B. So content of A into B, store answer in B and A. So higher byte is stored in register A and lower byte will be stored in register A, and higher byte is in B and lower byte is in register A. See the example here. Let the content of A is 05. Now here I am writing instruction move A comma hash 05. That means load data 05 into register A. Here move B comma hash 05. That means load data 05 in register B. MULAB means 05 into 05. The answer is 25 in a decimal. In hex it will be 19H. It is 8-bit. So as I told, the lower byte is always stored in register A and the higher byte is stored in register B. Here we have answer in 8-bit. So that is stored in register A and register B will be empty by default. So here we have two operands, operand A and operand B, and we have opcode, that is operation MUL. So you can see one example. Say write an assembly language program to multiply the content of B with the content of A and store result in 50H and 51H. Let's say in A we have data 22H. Let's say in B we have data 33H. So MULAB, that means multiply the content of A with B and store. So after multiplication, the A will be having lower byte, that is stored in 50H, and B will be having higher byte, that will be stored in 51H. And these two instructions are for keeping the program in the loop. Now let's see division instruction. The syntax is DIV. So function that A divided by B and store 16-bit result in register B and A. So it works in two steps. First of all, A is divided by B, that will be first step. In second step, the quotient will be always stored in register A and remainder is always stored in register B. So you can see we have content of A divided content of B, store in A quotient and store remainder in register B, and the syntax is DIV-AB. So here you can see, suppose in A we have data say 95, in B we have data 10, it will do multiplication, and after that it will store in A the quotient, that is 9, and in B it will store the remainder, that is 05. So you can have program here that divide the content of B by from content of A and store result in location 50H and 51H. So see here, in A we have data 22H, in B we have data 33H. We are doing a division, so DIV-AB. So quotient which is in A will be stored in 50H, and in B it will have remainder, that is will be stored in 51H, and the program will remain in the loop. This is always at the end of any program. So for division we have to use DIV-AB, and for multiplication we have to use MUL-AB. So just have a look. A divided by B, quotient in register A, and in B we have always remainder. This is the format. So if any doubt, please mail me on this mail given here, faizahmadkone@gmail.com. Thank you very much.